So I'm going to use an example of what my 99th grad student worked on. And it actually started out 2.5 years ago when I was on a family trip to New York City. And we were in a blue jeans store in Manhattan called Abercrombie and Fitch. And my daughter, who was 16, needed a pair of blue jeans. So that's my representation of a pair of blue jeans folded up. Now, the Abercrombie and Fitch store is about the size of this room, and within it there's well over 100,000 pieces of merchandise. And every piece of merchandise has a little thing called an RF tag on it. It costs about 5 to 10 cents. It's not just a passive thing for if, for example, if you walk out of the store, yeah, the bells will go off, but it's also for inventory control. So it can be interrogated by some equipment, and I've drawn it as a box. So you can think of it as sort of like an access point. And so, for example, in the store, the merchants can ask how many size 10 blue jeans are there, and they'll get the answer. My daughter wanted a pair of blue jeans, and in fact, it turned out that they had that because they went and interrogated. But when they went over to the stack where it was supposed to be, they couldn't find it. So it had been misstacked, and it was somewhere else in the store, and they had absolutely no idea. Now, I have some friends who have been working on a little company doing RFID tag type of circuits. So not in designing the tags, but in designing the tag readers. And I was chatting over coffee with one of them after this trip, and I was saying, geez, you know, what we really need is something which not only is a tag reader that reads the information stored on the RFID tag, but also something which tells us where it is. And that kind of goes across several disciplines. So this is showing, so this is showing the tag reader and a pair of blue jeans which got put in the room. And really, we know that it's somewhere within the size of, we really want to figure out where it is, because there's 100,000 other pairs of blue jeans. So in order to kind of solve this, we did it really at 3 levels or 4 levels. So first of all, just for working with the tag, we have to use wireless communications. So that is maybe fairly standard, except there are certain tough issues with it, but you got to do signal strength determination. But then there's something else. To find it, you can try to find it with an angle and range. So it's sort of like a radar would work, but it's a real problem. You can't use standard radar types of approaches because the ranges are way too small. You're trying to find something and determining that it's 10 meters away and not 15 meters away, as opposed to a radar, which is where you're dealing with tens of nautical miles. So it was kind of a different way of doing it. And then the antenna. Well, okay, there are standard ways of doing direction finding, but they don't work. So we've got the direction finding for using radio navigation or the GPS. We got the radar, and we got the wireless comms all coming into play. And what I did with my friend in the S5 Systems is I did bring on one of my graduate students, and we did get Ontario money in order to support the student, and he ended up coming up with this gadget over there, which is something which, if you're an antenna designer, you would assume can't possibly work. But it does, and it works extremely well. There's something called blockage, and because it's got these 3 towers, you would assume that, you know, for doing direction finding, that it's not going to work. But on the other hand, because of the nature of that antenna, and because it's something called circularly polarized, and because of the very unique orientation on the feed points, each antenna does not block the other antenna. And so we can do kind of an angle of arrival on that. So what we did was we put together a system. Oh, jumped too fast. And with these 3 technologies, from the tag reader, we can locate that missing pair of blue jeans, or that lost pair of blue jeans. Once again, using the radar. It's a special kind of radar. It's used for altimeters. And here it's a real problem, because with altimeters, you're in a time continuous wave. Here we're on a little short packet of time. but we can actually figure out, doing sampling correctly, the distance. And with the antenna, even though people would say that those antennas are going to block each other, no, they're not going to. We can find the angle of arrival. And then just from the wireless communications, we actually get enough signal power down to those, to the missing pair of blue jeans. Now, the interesting thing about this for this little startup, which is, you know, it's a Carleton grad started company, like most of them, is that some other little startups, one being Motorola, can't do this. And Motorola has a very large RFID initiative for doing geolocation of the RF tags. And twice now Motorola has flown up in their private jet in order to take a look at this activity. So what we are doing is, in a room about this size, we have an RFID tag and we move it around, and then on the computer screen we're showing where it is. So, you know, obviously the blue jean stores is a good thing because they've already got the tags in there. But what I was thinking about, every once in a while I read about a lost library book that just happens to have drawings by Michelangelo, and it's just been shelved incorrectly for the last 300 years. And so for libraries, this could be quite useful.